you take the derivative of the unit tangent vector. So the unit tangent vector is, again, showing you sort of the direction of the velocity. If you thought of the path as position, then r prime can be thought of as velocity. Okay, this can be velocity. This is the velocity turned into a unit vector. So the derivative of this is somewhat measuring the acceleration. It's measuring the acceleration as the direction of the acceleration vector. And then we turn it into a unit vector by dividing by its length. Now I would like to point out here that, like on our packet here, I have like 3 examples. And the 3 examples we have, the algebra work and the derivative work works out relatively nicely, but figuring this out by hand can get messy really fast. And so in terms of just us being able to work through problems in class and you doing some by hand, we're a bit limited to the types of functions, and hence after your test we're going to explore this topic a little bit more, and we'll be using software to, you know, do some of the really messy algebra that can arise if you try to work through one of these by hand. Okay, but the one we have, it turns out fairly clean, so I can kind of keep going. If we found t prime first, okay, here's t, so I'm taking its derivative, so it'll be minus 5/6 cosine, and then it'll be minus 5/6 sine, and then the derivative of a constant is 0. So that's just t prime. If I find its length, then I find the length like I find the length of all vectors. I square the x, and I square the y, and I square the z. Oops, I was using t and not A's. Okay, so looking at that, the cosine squared plus the sine squared is still going to equal 1. And so that reduces to 5/6. Because you'll factor out the 25/36. And then that'll give you that times cosine squared plus sine squared, which will equal 1. And then the square root of 25/36 will be 5/6. So that's the length of my t prime. So n, which I forgot to stick the n. The unit normal vector is t prime turned into a unit vector. So if I take this and I divide it by 5/6, then I just get negative cosine of t, negative sine of t, 0. So my normal vector for this particular example is that. I'll go ahead and graph it. I might change my artwork.